Biology Part 100. When this happens, there is an immediate change in the oscilloscope display showing that the microelectrodes has entered a negatively charged region. In fact, the whole of the inside of the axon is negatively charged, so that there is a constant electrical potential difference across the axon membrane. As a result, a steady negative potential, usually about 70 MV, is negatively potential, usually about 70 MV is recorded. This steady potential is called the resting potential, and the mechanism which is underlying and the mechanism that underlie it are crucial for impulse production. Before considering these mechanisms further, it is helpful to know a little more about the electrical nature of this impulse itself. The axon can be made to produce impulse if a second microelectrode is inserted, then used to deliver the electrical impulses to axon. Small negative and positive pulses, called sub-threshold stimuli, do not produce an impulse, but as the size of the positive pulse is increased, a definite threshold value is reached. Above the threshold size, each stimulus pulse causes a rapid all or nothing response in the axon. Giving rise to the electrical event called a nerve impulse. The impulse travels rapidly along from its point of origin as a wave electrical activity. Significantly, its size and shape remain constant, so the electrical message reaching the far end of the axon is unaltered. The figure shows that the electrical event, which can be recorded at any point in the axon, as the impulse travels past, the impulse begins with a phase of depolarization, during which the potential difference across the axon membrane is reduced. The potential across the membrane is then reversed, so that there is a definite overshoot when the inside of the axon becomes positively charged. This is followed by a phase of repolarization, which leads in turn to an undershoot, during which the potential recorded is more negative than the normal resting potential. The undershoot usually dies away gradually until the resting potential is restored. During the early part of the undershoot, the axon is completely unable to produce a second nerve impulse, even if the strongly stimulated. This is known as the absolute refractory period. During the latter part of the undershoot, called the relative refractory period, the axon can produce an impulse, but only if a stronger than normal stimulus is applied. These refractory periods are important because they affect the frequency at which nerve impulses can be carried. The normal maximum frequency of impulse is around 100 seconds, but can be as much as 1000 seconds in some specialized neurons. Impulses from many different animals correspond remarkably closely to this general pattern. The duration of the impulse is the commonest variable, with the impulses recorded from the most vertebrate neurons being significantly shorter than those from most invertebrate neurons. Well, we'll talk about more the propagation of nerve impulse in our next video. Right now we put an end to it and move ahead. That's all for the day. We'll have more videos tomorrow and we'll talk about biology. Right now it's the 100th video on biology, and that's all for the day. Bye bye. Take care. Talk to you tomorrow. See you tomorrow.